So, in the United States, doctors perform over 50 million surgeries a year, which is a ton. And if they were operating at a 99.9% accuracy rate, a success rate that, I mean, most businesses would absolutely celebrate, surgeons would still make nearly 12,000 catastrophic errors every single year. Today, we're looking at a methodology that, well, it refuses to accept 99.9% as good enough.
Right, because when you look at systems at scale, 99.9% is actually kind of a disaster. It feels like you're doing well, but, the math tells a very different story.
Yeah, and that is exactly why we're taking you on a deep dive today. We're pulling from a massive stack of research, primarily focusing on the principles laid out in Six Sigma, a complete step-by-step guide.
This is a great foundational source.
It really is. And our mission today is to unpack this relentlessly data-driven approach.
Mhm.
We want to show you how to shift an organization from, making educated guesses to actually proving solutions. And we're not just talking about manufacturing here.
No, not at all.
By the end of this, you'll see how to think in a process-oriented way, solve problems systematically, and apply this to your daily professional life. Whether you run, like, an IT help desk, manage a supply chain, or direct an HR department.
The overarching theme here is moving away from brute force. I mean, when a process breaks down, say a team is missing deadlines or an HR onboarding is taking way too long, the knee-jerk reaction from management is usually, we just need to work harder.
Right. Everybody put in more hours.
Exactly. Or they rely entirely on their gut intuition to sort of patch things up.
It's like trying to fix a jammed office printer by just pressing the print button harder and faster. It just doesn't work.
No, it never does.
But before we get into how to actually fix the machine, we have to define what quality even means in this context. Where does the name Six Sigma actually come from?
Well, it represents a statistical level of near perfection. Sigma is a measurement of standard deviation. So if you achieve a Six Sigma level of quality, it means your process produces just 3.4 defects per million opportunities.
Wow, 3.4 out of a million.
Yeah. In a percentage that is 99.9996% defect-free.
Which brings us back to that surgery statistic from the start.
Yeah.
I mean, 99.9% sounds amazing to a layman. But that is roughly a 4 or 5 Sigma level.
Right, which leaves room for a lot of errors.
A ton of errors. At
Right.
5 Sigma, you get over 230 surgical errors a week in the U.S. But if the medical field operates at a 6 Sigma level, that drops to about 174 errors a year nationwide.
That's incredible.
Just over 3 a week. You are 68 times more likely to experience an error at 5 Sigma than at 6 Sigma.
And the financial implications of that gap are staggering. I mean, consider a massive e-commerce day, like Amazon on Cyber Monday processing, roughly 36.8 million orders.
Okay.
If we assume a very conservative cost of $35 to fix a single order error, paying for shipping, customer service time, replacing the item, at a 5 Sigma level, those errors cost the company over $300,000 in a single day.
Ouch.
Right. But at 6 Sigma, that cost drops to about $4,300.
So the gap between good enough and 6 Sigma is hundreds of thousands of dollars.
Literally. Yeah.
Okay, so how do they actually get there? What is the philosophy driving those numbers?
The absolute core mindset is that variation is the enemy. Variation is the root cause of every defect.
So not just mistakes, but inconsistency.
Exactly. If you do something the exact same way every single time, you get the exact same result. So the goal of Six Sigma is to find the variation and eliminate it.
Let's ground this a bit. Say I own a local pizza shop, and I'm noticing inconsistent amounts of cheese on the pizzas. Sometimes it's a mountain of cheese, sometimes it's bare.
Right, that's your variation.
Okay, so my gut instinct as a manager is to just buy a 1-cup measuring scoop for the staff. Problem solved, right?
Well, not necessarily. I mean, you've introduced a tool, but variation still exists in how the human beings actually use it.
Oh, because they scoop it differently.
Exactly. One employee loosely pours the cheese into the cup, another packs it down super tight, another leaves a heaping mound on top. You still have variation.
So how do you fix that?
To eliminate it entirely, you have to standardize the process. You train them to overfill the cup, and then use a flat spatula to scrape across the top, leveling it off perfectly every single time.
Okay, I like that. That makes total sense for pizza. But if the goal is eliminating variation, how do we systematically execute that in a giant, complex business? There has to be some sort of engine behind this.
There is, and it's really the central framework of Six Sigma. It's an acronym, DMAIC. DMAIC. Define, measure, analyze, improve, control. This is basically your roadmap for improving any existing broken process.
All right, let's unpack this step by step because I think a lot of managers completely misunderstand how to actually solve problems.
Oh, they absolutely do.
Most managers, they do the D. They define the problem, like our customer service is too slow, and then they completely skip measure and analyze and jump straight to I, improve.
Yep, they just buy new software or fire somebody.
Right. And by skipping those middle letters, you aren't solving a problem, you're just guessing.
Exactly. You are basically beta testing random solutions on angry customers. And DMAIC prevents that. It forces you to start with D, define. And in Six Sigma, you define every problem as a mathematical function, y equals f of x.
Okay, take me back to high school algebra. What does that mean here?
So y is the outcome, the headache you're currently experiencing. The x variables are the inputs, the hidden root causes that create the headache.
And defining the problem isn't just complaining about the headache. The source material emphasizes creating a project charter. You have to set incredibly strict scope limits.
Yes, you need SMART objectives. Specific, measurable, achievable, relevant, and time-bound. You have to explicitly state where the process begins and where it ends.
Why is that boundary so important?
Because if you don't define the boundaries, you get scope creep. You try to fix an HR issue and suddenly you're like investigating your software vendor's global supply chain. It just spirals out of control.
Yeah. So to prevent that, you really need a map. You need to know exactly what territory you're looking at.
That's where a tool called the SIPOC map comes in. SIPOC.
What does that stand for?
Suppliers, inputs, process, outputs, customers. It's a brainstorming tool built using what they call swim lanes.
Walk me through that. Let's say we are looking at a commercial printing company.
Sure. So in your first swim lane, you have your suppliers, the paper and ink vendors. They provide the inputs, which are the physical paper and the digital customer files.
Okay, making sense.
Those inputs go into the process, which is the actual sequence of running the copy machines. That generates the outputs, the finished business cards, which finally go to the customers.
Got it.
You literally draw a box around the process part. If a supplier issue is outside your control, it goes on the board, but it isn't part of the DMAIC project you are overhauling today.
Okay, so we've defined the problem and mapped the boundaries. Next is M, measure. This is where we create a baseline performance metric. We have to know exactly how the process is performing right now, today, before we change anything.
Exactly. You're moving from a rough, intuitive draft of the problem to a final draft backed by real, hard data. You are calculating your defect rate.
And this is where that DPMO metric from earlier is crucial, right?
Yes. DPMO, defects per million opportunities. It's really the great equalizer. It's a mechanism that lets you compare the error rate of a small pizza shop with a massive hospital system on the exact same scale, because you're normalizing everything to 1 million.
So we're taking the number of defects, dividing it by the total opportunities for an error, and multiplying by 1 million.
That's the formula. It gives us a universal baseline.
What about standard deviation? How do we visualize that? Because math can get a little dry.
Think of it like throwing darts at a dartboard. If your darts are scattered all over the board, you have a high standard deviation, a widespread.
Meaning things are unpredictable.
Right. Your process is wildly unpredictable. But if all your darts are tightly clustered right next to each other, even if they aren't on the bullseye yet, you have a low standard deviation.
Ah, I see.
Six Sigma wants that tight cluster because once you have a tight cluster, you can easily adjust your aim to hit the bullseye. But you can't fix a random scatter.
So we've measured the baseline. We know how bad the scatter is. Now we move to A, analyze. This is the root cause analysis.
Finding the specific X variables causing our Y headache.
And you have several tools here, right? Like the Pareto chart.
Yeah, the Pareto chart is a big one. It's based on the 80-20 rule, the idea that 80% of your defects are likely caused by just 20% of your inputs. You use data to narrow down the possible causes to the vital few.
So you're not trying to fix everything all at once. You're hunting for the specific levers causing the pain.
Exactly. You might also use a Fishbone diagram or Ishikawa diagram to visually break down potential causes into categories, like equipment, people, materials, or methods.
Or you could use the 5 whys, which is literally just asking why 5 times until you hit the foundational root cause, rather than just treating a surface-level symptom.
Right. And the key in the analyze phase is really understanding correlation versus causation.
Oh, that's a big one.
Just because two things happen at the same time doesn't mean one causes the other. You have to use hypothesis testing to prove that changing this specific X will actually fix your Y.
Which leads right into I improve. This is where we finally get to test solutions. We pilot the change.
Yep. You do risk analysis, maybe an FMEA, failure mode and effects analysis, to predict how our new solution might accidentally break something else.
Because you don't want to solve one problem and create 3 new ones.
Exactly. You optimize the process, you error-proof it, and once the data proves the new solution works, you move to the final and arguably most critical step. C, control.
Because if you just walk away, human nature guarantees the team will revert to the old way of doing things in 3 months.
Precisely. Control is all about sustaining the improvement. You implement standardization, you create control plans, standard operating procedures, or SOPs.
So you're locking it in.
Yes. You set up KPIs and control charts to constantly monitor the process. You build the preventative measures directly into the system so the problem physically cannot return.
So DMAIC is basically like being a doctor. Define is asking the patient where it hurts. Measure is taking their vitals. Analyze is running the lab test to find the exact infection.
I like this analogy.
Right. And then improve is prescribing the medication and verifying it works.
Mm-hmm.
And control is the follow-up visit and the lifestyle changes to make sure you stay healthy.
It is, but with one major difference. A doctor relies heavily on past case studies and their own gut experience to make a quick diagnosis. DMAIC demands you assume you know absolutely nothing about the patient until the data proves it.
No, that's interesting.
You cannot rely on your past experience to skip straight to the prescription.
That is a great distinction. And a quick note here. Sometimes a process is so completely broken, or maybe it doesn't exist yet, that DMAIC won't work. For that, the source talks about using DMADV, define, measure, analyze, design, verify.
Right, you use that to build a process entirely from scratch. But you don't use DMADV if the process just needs a tweak. Use the right framework for the right problem.
Okay, wait, hold on. I need to push back here.
Okay, go for it.
I am putting myself in the shoes of a lot of our listeners right now. Let's say I work in human resources, or maybe I manage a creative marketing team. I am dealing with messy human dynamics, office politics, people. I am not on a factory floor stamping out metal widgets.
Right.
You cannot put human behavior on a conveyor belt.
Yeah.
Can these rigid mathematical principles really apply to, say, an HR department?
Absolutely, they can. And honestly, this is the biggest mental hurdle for people to get over. The Six Sigma mindset views the office as a people-powered factory.
A people-powered factory.
Yes. Any process that has inputs and outputs contains measurable variation. And where there is variation, there are defects.
Okay, walk me through a vivid example of that. What does a defect actually look like in HR?
Let's look at employee recruitment. It's a massive pain point for companies. The input is a job requisition from a manager. The output is a fully equipped, trained new hire sitting at their desk.
Right.
What is the defect? The defect is that it takes 90 days to fill a role, and by the time you actually make an offer, the best candidates have taken other jobs. That delay is a defect, a Y variable.
Okay, I see. So how does an HR director use DMAIC to fix that?
First, define. Draw the SIPOC map. Where does hiring start? Is it when the manager emails HR or when the job is officially posted online? Define the exact boundary.
Right, no scope creep.
Exactly. Next, measure. Don't guess why it's taking so long. Collect the baseline data. How many days does the resume sit in the recruiter's inbox? How many days between the first interview and the second?
So you're finding the exact bottlenecks in the timeline.
Yes. Then, analyze. Use the 5 whys. Why is there a 14-day gap between the interview and the offer letter? Well, because the hiring manager takes a week to review the notes.
And why is that?
Why? Because the interview rubrics are vague and they have to reread everything to remember the candidate. Boom, you found a root cause, an X variable.
Oh, wow. Then improve. You standardize the interview rubric so managers can score candidates in, like, 5 minutes. You pilot this with one department, and suddenly the time to hire drops from 90 days to 45 days.
And finally, control. You build a new rubric into the HR software so a manager physically cannot submit an interview review without it. You set up a KPI dashboard to monitor the time to hire metric weekly.
That is fantastic.
You have just used Six Sigma to move HR from a reactive, activity-based department to a proactive, data-driven powerhouse.
That is fascinating. It applies to payroll errors, high employee turnover, IT service ticket delays, procurement bottlenecks, anything with a start and end point.
It really does. But here's the reality check. Implementing this isn't just about handing everyone a calculator and a Pareto chart. The technical tools are useless without the right culture. Six Sigma can and does fail all the time.
Wait, really? Why? If the math is perfect, why does it fail?
Because of leadership. Six Sigma requires absolute top-down commitment. Historically, if you look at champions like Jack Welch at General Electric
Right.
or Larry Bossidy at Allied Signal,
Right, the pioneers of this.
yeah, they didn't just endorse Six Sigma, they tied executive bonuses to it. They made it the core language of the company.
So if a middle manager tries to run a DMAIC project, but the VP isn't willing to allocate a budget for the improve phase, the project basically dies on the vine.
Exactly, it's dead in the water. Furthermore, leaders have to manage the human element, the change management. People naturally resist change.
Of course they do.
When you start measuring processes, employees get terrified. They think the data is going to expose me and I'm going to get fired.
Oh, that makes sense. They feel like they're being watched.
Right, so leaders have to clearly communicate that Six Sigma is about fixing the process, not punishing the people. If you don't overcome that fear, employees will hide the data and your analysis will be completely worthless.
Okay, that brings up an interesting question about methodology. If you've been in business long enough, Six Sigma is not the only buzzword you've heard.
Oh, definitely not.
There's total quality management, Kaizen, lean, agile. How does Six Sigma fit into this, methodological multiverse?
Well, it's important to know which tool to pull from the toolbox. Let's take total quality management, or TQM, which was huge in the late 20th century. TQM is a broad cultural shift toward quality, but it often works toward a specific defined goal.
And once you hit the goal.
Once you hit that goal, the program can lose momentum. Six Sigma is much more mathematically rigorous. It's an ongoing culture of continuous improvement that technically never ends because standard deviation can always be tightened.
And what about Kaizen? You hear that a lot in manufacturing.
Kaizen is a Japanese term meaning change for the better. It's about small, incremental, daily improvements made by everyone on the floor. Six Sigma is usually a larger project-based breakthrough led by highly trained experts, often called green belts or black belts.
The one you hear paired together the most, though, is lean. Lean Six Sigma. What is the actual difference between the two?
Lean is entirely focused on eliminating waste and extra steps. It's about flow and speed. Think about assembling a hot dog at a concession stand.
Okay, I'm hungry, but go on.
Does it take 4 different people to grab the bun, cook the dog, add ketchup, and hand it to the customer? Or could one person do it faster without passing it around? Lean removes the waiting, the unnecessary movement, the over-processing.
So if I'm running a commercial kitchen, lean is throwing out the clutter, organizing the fridge, and getting rid of the broken spatulas so I can move faster and more efficiently.
Exactly.
But Six Sigma is calibrating the ovens so my cakes bake at the exact perfect temperature every single time.
That is the perfect way to look at it. Lean eliminates the waste and the speed bumps, and Six Sigma eliminates the defects in what remains. That's why Lean Six Sigma is such a powerful synergy.
And both of them must ultimately tie back to a critical concept mentioned in the text, the VOC, or the voice of the customer.
Yes, because it doesn't matter how fast or how perfectly you bake that cake if the customer actually ordered a pie.
Right.
Quality is ultimately defined by the customer's expectations, not your internal efficiency metrics.
If you are perfectly executing a process that the customer doesn't care about, you are still failing. You have to translate the voice of the customer into critical to quality requirements before you even begin the DMAIC process.
Exactly. You ask, what does the customer actually value? What are their non-negotiables? If you're an IT help desk, maybe the customer doesn't actually care if the ticket is resolved in 10 minutes, but they care deeply about getting a daily status update.
I see. So if you use Six Sigma to speed up the resolution time to 5 minutes, but ignore the communication.
You've missed the voice of the customer. You solved the wrong problem.
Wow. So what does this all mean for you listening right now? We've covered a lot of ground today. We've talked about the DPMO math, the danger of variation, the DMAIC engine, the SIPOC maps.
We really have.
And now this applies just as much to an HR desk as it does to a factory floor.
But the most important takeaway is that Six Sigma is not magic. It is not a silver bullet that will instantly cure a toxic workplace culture or fix a fundamentally flawed business model. It is a rigorous tool.
It requires meticulous data collection. It requires leaders who actually buy in and protect their teams. And most importantly, it requires a profound willingness to challenge your own assumptions.
You have to abandon the ego-driven idea that you just know what's wrong with your department. The core philosophy of everything we've talked about today boils down to one rule. Don't rely on assumptions when data can provide evidence.
Stop guessing. Don't just hit the print button harder. Which leaves us with a final challenge for you to take into your work tomorrow morning. Think about the biggest, most frustrating bottleneck in your week right now. That one process that always seems to go wrong, the one that makes you want to pull your hair out.
We all have one.
If every problem is just a mathematical function, if y equals f of x, what is the hidden x causing your headache? And are you relying on your gut to find it, or are you going to actually measure the data? We'll leave you to think about that. Thanks for joining us on this deep dive into Six Sigma. Start measuring, stop guessing, and we will see you next time.